Just a little more about APH and myself. As Laura and I are concerned, APH is one of the largest manufacturers of materials for education and aids for people who are blind and visually impaired. So Laura and I work together to develop products that help improve and enrich the lives of people who need those aids in their everyday and their education. We focus a lot on education, kindergarten up through grade 12, and even beyond that into college and even into adulthood and late in life, senior living. We really appreciate you all having us here today. We're excited to talk about especially how it relates to map making and geography and those kind of topics. In my position at APH, I basically take Laura and her team's ideas, and we figure out how to make them at APH. So that means we have a pretty large manufacturing facility, and we're actually doing a tour tomorrow. Maybe some of you are signed up for that, so I look forward to seeing you there. If you're going to be there, Laura and I will be there to talk about our products and kind of give you a nice personalized tour. So that'll be fun. So what I wanted to talk about was first is just how we manufacture products like geography products and stuff. And really it's there's sort of a decision to make when you're sort of early in the process of designing these products. So do you want something that's going to be robust and last a long time? It's something that's kind of a discarded throwaway. Maybe it's a one-time use in a classroom, or anything in between there. So we make those evaluations and we design and manufacture based on that. So one of the very, I would call it inexpensive and efficient ways to make tactile graphics in general, which relates to map making, is we call it, well, the brand name is Swell Paper. It's called micro capsule paper. Is anyone familiar with micro capsule paper? I see some hands here. Okay. So if you're unfamiliar with how the technology works, it's a specially coated material, specially coated paper, and it interacts with the carbon that is in toner-based inks. So especially like black toner has a lot of carbon in it. And as you introduce that to an intense infrared light, it raises the carbon in that tactile graphic, and you get a nice tactile line. The benefit from this is you can produce a lot of them in a little bit of time, and there's no need for any kind of upfront tooling costs. You don't have to create a physical tool like an embossing tool or something. So we can just churn those out pretty quickly and include those in our products for low cost to our customers. The problem with that, though, is that those, they have sort of a shelf life. They're going to deteriorate after a while. So this is not something that you want, like maybe that's going to be on display in a classroom. This is a throwaway, something that someone might use once, like in a textbook or in an accessible test. We do a lot of our graphics for tests and accessible tests on Swell paper. So yeah, that's, and again, it'll raise anything with carbon in it, so obviously a lot of black ink. You can do like full color. You'll get some raising of the other colors, but not as high of a tactile image as the black. So this is important to us because we have we have specs we adhere to for Braille and tactile graphics. So we want to make sure that the products we're putting out there are legible to people who are tactile readers, and so that's it's just a nice way to get sort of quick information to especially students who are using textbooks or again like standardized tests and things like that. Another method we use to produce tactile graphics is embossing, plate embossing. We use zinc plates or copper dies on a press. So this does, for us, this is a great example Laura has here. This is this is just a US tactile map. Just shows the outline of the United States with the states labeled, and I believe a scale on there as well. So we use a zinc plate to emboss this on a press. We'll print that first and then run that through our press to emboss the lines and braille into that. So just kind of a very basic overview. You know, this would be used by young children in the classroom.
It's aimed for K through 12 because social studies standards K through 12 require a US map. So it's for K through 12, but the way that we've made it, the way that we've made it, it's accessible for everybody. So you could buy a pack of these maps, bring it into a general education classroom, and every single student in that classroom can use the same map instead of buying print maps for your print kids and tactile maps for your braille readers. You can just buy a print tactile map and use it for everybody.
So this is sort of a step up from the Swell graphics in that there is sort of an initial investment in your physical embossing tool. Zinc plates, though, are very inexpensive at APH, so this actually still becomes a pretty cost-efficient piece of material that we can provide to students in the classroom. And like Laura said, we really try to bridge that gap between what the sighted peers and the peer with visual impairment have, and the less different that is, the better. You know, no one wants to be the odd one out with a large stack of Braille books, you know, or something like that. They want to fit in with their peers. So materials like this are great for that. And we do a lot of this, again, also for accessible tests and textbooks. If there's a reason maybe we need more color or maybe more detail, or just lasts a little bit longer, we might go with plate embossing versus swell paper graphics. And then we can also do larger sizes. So this is a pretty large size sheet. With swell paper, we're kind of limited to like standard 8.5 or 11.5 by 11 sheets of paper. So this one we can go much larger on. Another method to producing tactile graphics is we do tabletop thermoforming. So, and I see some head nods. People are familiar with tabletop thermoforming, a few of you. This is a pretty, one of my favorite methods. I find it pretty interesting. We make, there's a lower upfront tooling investment in that we make paper-based masters. So we run these on a wide format UV printer, and as the head goes across that page, it lays down ink and is immediately cured by a UV light. And as it does multiple passes, that ink builds on top of itself. And so after about like 5 to 7 passes, you get a nice tall tactile graphic. You can print Braille on there. And we take, because that paper master is porous and it has, you know, it allows air to pass through it. We put that on a tabletop thermoform. We put a piece of plastic on top of that, clamp it down, introduce heat and vacuum, and that plastic sheet sucks down over the paper master, and into the sheet you have your graphic and your Braille formed into it, and it's ready to go after that. Now the nice thing about this is pretty robust as far as inexpensive tactile graphics go. Because it's plastic, kids can slobber all over it, they can put it in their mouths. I might slobber over it a little bit, honestly, if I'm eating lunch over one or something. But this is great for the classroom especially. We use it in a lot of textbooks. This is something we might do if we're going to produce a lot of copies of something. We get maybe about 100 pulls off of a graphic. We might have to make a new master. But those masters are pretty inexpensive, and there's, you know, other than the print file to make the master, there's no real upfront tooling. So it's a fun method, and again, we use that in a lot of our books and instructions and things like that. One last sort of inexpensive method that we have is a lot of people have a lot of people that we serve have like at-home embossers. So these embossers basically use a printhead-like thing to emboss an array of dots. So what they can do is they can, instead of a solid line like you might see on the materials going around, it's a dotted line, but it still creates a simple tactile graphic. But this is nice if you want just like a quick graphic of maybe the outline of Kentucky, or so people will download files off the internet and run those, and then they can just put it in front of a kid just for a quick reference. The last method, and our more robust method, is we use vacuum forming, which is similar to tabletop thermoforming, but this is in a larger scale. So we make proper vacuum form molds out of fiberglass, and these are going to be really more like topographical style maps, things with a lot of detail, a lot of sculpting, and you can really capture a lot more information in a lot larger scale. So like, we have like giant posters, and if you come to APH tomorrow, you'll see this. But that we will print onto like a vinyl or some other type of plastic, and again, introduce heat and vacuum to a vacuum form mold to draw that plastic down over that and mold the topographical information.
That's how the overlay on that.
Yeah. So if you look up on the screen here, this is a flat printed globe, and we vacuum form into clear a top hemisphere and a bottom hemisphere to apply over that to give tactile information. So it's got, you'll feel the mountains ranges, you'll feel topographical information. It'll mark like national capitals and things like that. So that latitude and longitude lines, things like that, the equator. So and that's probably my bread and butter, is the large scale vacuum forming. And if you guys come tomorrow, again, we can kind of show you what that looks like at APH. And the last thing I'll say about that is these are like very robust. These are things that are meant to be displayed in a classroom, be used or shared by multiple students over multiple years. But at the cost of a higher upfront tooling investment, and then a little bit more of a expensive per part cost. So these are things we're very sensitive to as we design products, because our customers use federal quota dollars to buy our products, and they only have so many dollars per year. So the more efficient and the less expensive we can make our products, the more people can buy, and the more they can enrich their lives with these various educational items. So with that, I will turn it over to Laura to talk just a little bit about some of our products.
Hey guys, so I won't take up much time because I've only got a few minutes anyway. I want to leave some time for you guys to ask us questions, give us comments, things like that. So we're leaving like 5 minutes at the end of our talking. But I did want you guys to know, for those of you who haven't come up to see the globe, I want you guys to have a chance to come up and see it if you have some time, maybe during our question period or even after the presentation. That globe is different than the one that we have pictured up here. That is a talking tactile globe. So that is a globe that is going to serve sighted students, Braille students, audio learners, low vision students, because we do have the contrast put on there. So that is a universally designed globe. It's made from a Spanish company, but we have been the ones that have guided the North American labels on there, because it's not a North American product. It will be once we release it later this year, this fiscal year, not before December. Sorry, don't get excited. But it is going to be pretty cost efficient as well. For a tactile globe, it's going to be probably under $300, which is amazing. And it's got that audio component on it as well. So it's gonna be, in a general classroom, and then everybody in the whole classroom is gonna be able to use it. And sighted people love audio too, so they're gonna dig that. And like Andrew said about the everything going in their mouths, it's a thing. It's definitely a thing with young kids. It's even more so a thing with young kids with multiple disabilities. That's how they explore the world. So everything that we produce, we need to make sure that it can be sterilized, and that it's not going to be a choking hazard, or we make sure that we put the choking hazard label on there. There's a lot that goes into a lot of decisions that have to go into product development that we have to consider. So obviously our cost and the cost to our customer is priority one for me. I know different product managers feel differently about that. I obviously don't send out anything that's low quality, but the cost is super expensive because they only have so much. And now I'm going to open it up for you guys to ask us questions, give us comments, come up and see the globe. You've got 5 minutes here. So she's asking about the spacing for Braille and tactiles. So the globe that you see on the screen up here, the overlay that we have, it actually has tactile marks and Braille on it. It is too tactually cluttered. To be perfectly honest with you, it has served a great need and it is doing really well. I don't have Braille on our new globe for that reason, because if you want enough space, you have to make it much larger to put the Braille on there. So like that globe isn't going to tell you where a certain country is, but it's going to tell you where a geographic feature is.
And sorry, just to add to that, so another thing we might do is break up maps into sections or different, we might focus on like regions, like if it's like North America or something like that. So that way you can get more information on there without cluttering it up. So we might make like a booklet instead of just a single map that someone can flip through and reference. So.
And as you'll see on that map that I passed around, with Braille, we use lead lines when the area is too small. So if you look at like the northeast of the map, the American map there, you'll see that there's lead lines leading off of the graphic, and that's so that that Braille doesn't clutter the border lines. That's a standard that we always follow.
Question over here.
Hi, just a quick question about the legibility aspect of it. Do you have staff or volunteers on site who are maybe low vision that test the products?
We employ a lot of visually impaired folks at our company. We do have quality assurance. We do have what does PSIE stand for?
Product. I don't know.
We have plenty of quality checks that go in. So we live in acronym world, in our world. So we just throw letters around like it's alphabet soup and, expect everybody to know what we're talking about. But no, we have a lot of stop gaps in our process. Even in the development process, we have a gate process. So we have to meet certain criteria before we can move forward in our development cycle. And once we have prototypes, we send those out for field testing. So we have people in the field that actually get their hands on our products, give us feedback, and then we have checks in-house while it's going through production. So we definitely have somebody that has a visual impairment. They touch everything that we make.
Yeah, that one of the statements I was
they have
going
to
to
turn
have
the
is
pen
that
on first.
no one is using the wand on the globe over there. They're going over and they're touching it and saying, "Oh, how nice," and walking away.
Well, it is tactile. It does feel great.
Yeah,
it's audio. It's got a pen that reads a code on the paint that's audio.
Yeah, but further to that, you had mentioned about there being this code in the paint. And so all that really comes to mind first to me when I hear that is things like striped or checkered paint. And how does that work?
It's actually, so there's actually a dot matrix pattern that is printed underneath the color. You can't see it with your naked eye, but you can see it with a micrometer. And so the tip of the pen is optically picking up that pattern, and it's matched to an audio file. And those audio files are loaded in the pen.
Yeah, that part, but it's so the code is applied before the paint. Mm-hmm. It's not.
I think I think it's part of it. I think it's all part printed together. It's all printed together.
So I see. It's still sort of like checkered paint.
Yeah, I like to compare it to like kind of like microscopic QR codes built into the print file. So what you can do, so you have like, whatever the code might be, you assign that then to like an audio file on the pen.
Or like chocolate chips in a cookie.
It kind of works like a barcode. That's,
Yeah.
that's like,
I
the
like
optical
the-
recognition works like a barcode.
I like the chocolate chip cookie analogy. It's a bunch of tiny chocolate chip cookies on there. Each one different, than the other one.
I did want to go over just like 2 quick things about tomorrow. If anybody is coming, please understand that we are under construction right now. So you'll go down Frankfurt Avenue and you'll see a construction zone. That's the printing house. Right after it, you're going to turn left into a parking lot, and that's where you're going to find the main entrance, is down in that parking lot. It's labeled, so you should see it, and both of us will be there starting at 8 tomorrow, so you can come on in your leisure.
All right, well, thank you. I think it was, yes, we'll do it. Thank you.
Oh, thank
And I
you.
was going to ask